Yourselves, please. I do like the structure of doing the learning on Monday, the extension on Thursday, and a quiz on Friday, but we'll see if that sticks. So, on your table, we have one column of percentages, one column decimals, and one column as fractions. And like I said, we have three different ways to represent a quantity. Our goal over this next week is to help us understand when is one more helpful to use than the other, and how do we go between them? How do we decide what they're equal to? And I gave you these, even though we're learning this week, I gave you these because I thought you had enough knowledge to figure out some or all of it. So 0.25, sorry, that's supposed to be 0.25 in that one. I have 1/2 for a fraction here. I have 10% here, and then 0.4 for that one. Okay, so that's what you're starting with, and you're asked to find out, okay, well, what's the percentage and the fraction that are equivalent to 0.25? So can anybody tell me the percentage? Macy? 25%. Now, how did you do that? Well, the 25 is natural, but why is it 25 without a decimal in it? Okay, I did ask for percent, but what is it that makes 25% equivalent to 0.25? Liam?
It's 100 multiplied by 100 or divided.
Depends on what you... I think you mean exactly what you do, but you represent it two different directions. So, how do you say this number formally? What I'm not looking for is 0.25.
0.25. 25.
Luke?
0.25.
I'm not looking for 0.25 or 0. I'm looking for
25.
I'm looking for the formal way that gives you the place value.
0.25.
No. Take out the point.
25.
Thank you. 25 hundredths, which if you flesh that out, tells you the fraction is 25 hundredths.
You can reduce it.
Oh, we do need to reduce it. So Carter, did you get the reduced version?
1/4.
1/4. Excellent. Okay, excellent. That's all you have to do? That's most of the week. You'll see. Okay? Starting with 1/2, can you tell me what that is as a decimal?
50%.
Not the decimal. Hold that thought. Macy?
The decimal or the percent?
The decimal.
0.5.
All right, 0.5, that's what we say, which means 50, or sorry, okay, you're ahead of me. You're ahead of me. You guys are so far ahead. 5/10, a.k.a. 50 hundredths, which is 50%, okay? All right, let me hear from somebody else on this one. 10%. Question? Or are you going to tell me the answer? All right, which one, Adeline?
Decimal.
What you got?
1.07. Huh?
8.7.
That's 10%. That's not a 7. That's a percent symbol.
Oh.
There you go. All right. Hang on. Let me hear from somebody else. What? 0.10. Good. Or you could have just written 0.1. That 0 at the end is not significant. Okay? 10% means 10 out of 100. Isn't that the formal way to say that number? 10 hundredths. Okay. Now, Luke, you got the fraction? What is it? That's a great starting point. But you know me, I'm going to ask you to reduce it. And it's what? 1/10. Excellent. Isn't that the way that you say the number 0.1 formally? 1/10? Do you see how much help you have with just one representation if you know how to speak the number? And then we get to this one.
40%.
All right, 40%. Good, I can go with that. 40%. And a fraction. Who can tell me what the fraction... They reduced... Rosalie, what you got? 4/10. Okay, great. Can we reduce it anymore? 2/5. All right. That whole chart embodies everything we're going to talk about this week. Okay? So some of you might be thinking, well, what do I have to do this week?
A lot.
I want you to be good at it, not just 5 or 6 people, but everybody. Okay? All right, so we're going to take some notes. I expect you to have at least a page here set aside. Okay? Now, if you go back to the checklist for just a moment. Okay? If we go back to the checklist, you'll notice we have 5 lessons worth of practice problems. Just 2 problems for 72, A through J for 73, and then some numbered problems. 74, 75, and 76 are just the practice sets. Okay? So, I don't want you to do them all one under the next. I don't want you to have 73 here and then 74. I don't want to do that. I want you to take the notes that we're going to write for each lesson, and then I want you to do the practice set on that page. Okay? So what that might, yes, leave some open space. If you write large, you might want to leave 2 pages. Okay, but I think you can squeeze these in. So I'm going to try and model that for you. Okay, but we've got to start with 72. So 72, let's see, what is 72 specifically going to talk about? Well, you got an idea that it's going to be multiplying a fractions chart. Okay, now we won't spend a lot of time on a fractions chart. The reason they give you things like that in this book is to help you have a plan of attack. Okay? Whether you're adding fractions, multiplying, dividing. Okay? So we're going to skip over that fractions chart because we're going to reiterate everything in the next few pages. Okay? But I do want to go over just a simple idea. When you multiply 3 fractions, and what I should say here is 3 or more because the rules don't change. But suppose we had, call this 72.1, suppose we had 3/5 times 4/7 times, let's say 6 over, what do you multiply by? 11. Something yucky. Okay. 2 plans of attack here. But it doesn't really matter which way you do it. You were just shifting steps from the beginning to the end or vice versa. You might be doing reduction at a different place than the person beside you. Okay? So what this essentially means is just 3 times 4 times 6 on top, 5 times 7 times 11 on the bottom. It comes as one magical super fraction.
Wow. Yeah.
Thanks for the reaction there. We want to look for things we can cancel, right?
Yes.
I don't know if I see anything yet. So if I don't see anything jump out at me, we're just going to continue and multiply. So I'm going to 3 times 4, what's that?
12.
12 times 6.
12 times 6 equals
72. Let's do the same thing on the bottom. 5 times 7. 35. And then 35 times 11.
3,300. No.
385.
Oh, you guys are
Close
fast.
enough.
Here's how I did that. 5 times 7 times 10. 35 times 10 is 350. Then I have 35 more. So there's 11. All right. That's it. Is that really all you do? You want to reduce if possible. They're not even, so I'm not going to do 2. 3 plus 8, let's see, that's 11 plus 5, that's 16. Does that mean it's a multiple of 3?
No. Yes.
No, it's not. They have to add up. 16 doesn't work, so it's not even. 4 won't work. 5 won't work. 10 won't work. 6 won't work because 2 and 3 didn't work. 7. Does 7 go into 72?
No.
No. It's not even, so 8 doesn't go.
9.
9 won't work because 3 didn't.
12.
We're going to stop. We're going to stop at single digits, okay? Okay?
12.
We're going to stop. Single digit. I'm not going to ask you guys to go beyond 10, okay? 12 won't work because 385 is not even. Once you start to get into those 2-digit numbers, you realize, well, if 12 is going to work, 2 had to work. And 6.
And 3. No.
Well, if 6 works, 2 or 3. Yeah. All right, so you got to think, I can rule out 12 because these smaller numbers didn't. Okay, so that's why the single digits are going to be the ones that we stop at. One other example here, 72.3. Let's say I asked you to find 1/4 of 2 1/5 of 4/3. Oh, I did skip it. Sorry. Skipped.
That 9.
Is it 2? A mixed number?
Yeah, it is a mixed number, but there might be an extra step.
Is that a 2 or a 6?
2.
It looks like a 6.
This?
Yes, it looks like a backwards 6.
Okay. Well, if it's backwards, it's not a 6.
Oh, yeah.
Sorry. It's a mixed number.
It's a mixed number.
It
Clearly
looks
they
like
were.
a backwards 6.
So, 1/4, you're cool. You can say that way. We are going to have to change 2 1/5 to an improper fraction. So you do have to convert when you're multiplying and dividing. So we'll get 11/5 here, and then we'll get 4/3 here. Before we move any further, do you notice anything that can reduce at this point? Macy? The 4 on top and the 4 on bottom. This is why that section about 10 lessons ago had you go through and do that. When you have a common factor on top and bottom, get rid of them. What does this become? 11 over 15. All right. 70. So what your note should look like, you should leave a little bit of space at the bottom of the page for the practice set from 72, and it's just 2 problems. But no matter, we're going to start a new page for lesson 73. Okay? So lesson 73. What is that? Well, we have some exponents to deal with. And we have decimals as fractions, okay? Decimals as fractions. And as you might have figured out, I'm going to talk a lot today. Okay, first of all, exponents. Have you seen them before?
Yes.
What do they look like, Ella?
So you draw your little line thingy and some numbers. Your line thingy.
Oh, so you mean this?
Yep. That's exactly what I meant.
Yeah.
You were going to tell me what it looks like. Yeah, all right. So, I know you would. I'll feel good about that. How do you say that?
What?
7 to the 3rd power.
All right. We don't actually say exponent. Well, I guess you could. You can say 7 raised to an exponent of 3, but more commonly people say 7 to the 3rd power. Another way people might say that is 7 cubed. Cube having an association with the number 3, 3-dimensional shape. So we're going to say 7 cubed or 7 to the 3rd power. Or some people will just stop and say 7 to the 3rd. Okay? But it's important that we know what it means. 7 to the 3rd power means 7 times 7 times 7. You see, exponents are just a way to represent a repeating multiplication pattern. I don't know what this one is. 343? That sounds like a balloon losing its air. Depending on calculator usage, which is a little bit up in the air for this point, 7, you have this little rooftop button, raise it to the 3rd power, 343. Okay, but that's all exponents mean. So when you get a problem like this, 73.1, let's suppose I asked you to find 29 minus 5 squared. 29 does not have an exponent in it. So 29 is just 29. But what we should do is replace 5 to the 2nd, or 5 squared.
20. Wait, no, it's not 20. It's 4.
It's 4 because 5 squared was what?
25.
25. Or an answer of 4. So that's all the exponents we're going to talk about in this lesson. just knowing what it means. Knowing what it means. And there's a really great problem on page 393 about 3 to the 4th versus 4 to the 3rd. You have to know what exponents mean to be able to calculate that. But the real meat of lesson 73 is decimal to fraction conversion. And you've already got a whole bunch of that from the warm-up, right? You already know a lot about that. But suppose I ask you to find 0.6. Let's call this 73.2. 0.6 as a fraction. And you've heard me say this before. It's not going to change. I do want you to reduce, if possible, as much as possible. Okay, so let me scroll a little bit. So the second part of lesson 73, we want to be able to write a decimal as a fraction. We've got to think, well, 0.6, I need to know how to say that. I know that we all think 0.6, but we really need to be saying 6/10. And when you say 6/10, doesn't that give you a fraction? Yeah, sure does. 6/10. So that's one step towards getting the final answer. But Liam, are you telling me we can take it further?
Yeah.
We can reduce it so we get 3/5. So if I were to rewrite 0.6, 6/10 as a fraction, it would need to be 3/5. You see, the general rule for fractions is to think about their place value. So if we take a look at another one here, 73.3, suppose I gave you 0.27. Okay? So we want to think about the place value of the number 0.27. We actually want to say the number, speak the number formally, mathematically. So we're going to say that how? 27 hundredths. Let's make sure we spell that last word correctly too. So you see the TH at the end? That indicates that it's lower than a whole number. So 27 hundredths, once you say it, you have the answer. It's 27 over 100. Which would be easy if I was asking you for the percentage. But I'm not yet. So, can we do anything with that?
Turn it into 27%.
I don't need to yet, but I will eventually. We're done. Some of the fractions will not be able to be reduced. And so you'll be finished at that point. So I'm going to do one more example on this one. And so that would mean if I take up my entire page, you would want to leave the next page blank for your practice problems on 73. Okay? So 73.4, let's say I ask you to find 1.234. Oh no. It's not 0 point something. Doesn't change a whole lot. But I want to know what that is as a fraction, or in this case, it might actually be a mixed number. Yeah, very good. So, how do you say this? 1 and. So the and, remember we clarified this at the beginning when we started just pronouncing numbers. When you say the number in words, you only use and when there's a... Oh, you guys got it.
Not for the thousands.
234 what? 234 what?
Thousands.
What?
Thousands.
I needed to hear you say it good. Very good. Thousandths. Again, hopefully you're seeing why we learned place value, why we learned to be able to say the number that way. 1 and 234 over 1,000. That one might be able to be reduced somewhat. Agreed? 1 and 117 over 500. I just divided them both by 2.
Yeah.
But being able to speak or say the number in words is the clue to helping you get the fraction. Question so far? No? All right, so I'm going to turn the page. I'm going to leave the next one blank for 73. 74. Well, how's 74 going to change? What new skill are we going to learn? in just a moment. Write fractions as decimals. Oh, and I have a great one to start with. So somebody needed to catch me up on 73?
Yeah.
So the first one I'm going to ask you about on lesson 74, again, lesson 74 is starting with a fraction, writing the decimal. All right. Carter, you caught up?
Yeah.
Awesome. So, 74.1. So, in the last lesson, we started with a decimal. You started with place value, right? You started with place value because we use a base 10 system with decimals. You got tenths, hundredths, thousandths, and so on. But now, I'm going to give you a reduced fraction to begin with. Your book starts with some easy ones, like 1/2 or 1/4. We're just going to cut to the chase here. Yeah, cool. 1/5. 1/5 is a fraction.
Oh.
What decimal? All right, hang on. Shh. Some of you already know this. You know it too? All right. Yes, you go back. 1/5. 1/5. Does that tell me place value?
Yeah, no.
I'm making this face to confuse you?
No.
Maybe. 1/5. Well, the only time we get place value, if you look back at the previous problems, was when it ended in tenth, hundred, or thousand. If you look at the denominator, it's not a 10, it's not 100, and it's not 1,000. Bummer. We're stuck, right?
Oh, no.
No, we can modify it to make it one of those numbers. So, there's going to be two strategies here that I tell you about. One of them is manipulating the fraction or writing an equivalent fraction so that you have a number that indicates place value on the bottom. Said another way, try to write the fraction so that you get 10 on the bottom, or 100, or 1,000. Okay? That's not a 9, that's a question mark.
Or a question mark.
Because a question mark has the dot. Otherwise, it's not a question mark. All right, so 1/5 equals what out of 10?
2.
2 out of 10. Now, how do we say that number? Oh, 2/10. There it is. That's the first way. Rewrite the fraction. Girls, you'll need to spend more time on the notes and less on your notes. Okay? Point 2 needs to be stated as 2/10. Using the fraction, it indicates what the decimal is going to be. Now, I said there's another way. I'm going to show you two ways. How do you say this? Not a trick question. What?
0.5 or 1/5.
1/5, which is not 0.5, is it?
No.
No, it's 0.2. What's another way to say 1/5 using an operation? What operation does a fraction communicate? Do this again. Sorry, I marked on my pants with a pen.
What? I forgot what you said.
I did too.
Well, I can do the little
How do you say this with an operation? Instead of saying 1/5, we can say 1/5.
1 divided by 5.
No, it's 1.
What? 1
Divided by 5.
divided by 5. So we're going to say 5 goes into 1 how many times? Now, have we learned how to do this?
No.
Yes, I think
Yeah,
so.
yes.
We're going to introduce a decimal because 5 won't go into 1, and then we're going to keep track of things by remembering, it doesn't go in. You line up the decimal, and then you start dividing. 5 goes into 10 how many times?
2.
2 times. 2 times 5 is 10. 0 left over. I'm finished. Do you see the same answer?
Yes.
Awesome. Now you have two ways to do it. I'm only asking you to do one. But you might need both of them depending on what the problem is. So suppose I gave you 3/8 equals what decimal? Now, 8 might be a more difficult number for you to convert to 10 or 100 or 1,000. Some of you can do it, I am sure. But what I'm going to stress on this one is that you need another way to do it. You need to be able to do the division method to help you. So a fraction communicates parts divided. So 3 parts divided into 8, or 3/8. That means 3 divided by 8. So we're going to write that division problem. We're going to do that division problem, and we're going to see how it helps us. We already know that 8 won't go into 3. So we're going to have to introduce the same strategy here. When you're dividing a larger number into a smaller number, we're going to use decimals. And I'm going to just start with 3 and see if that gets me to the finish line. Some of these could be nasty, as in the decimal goes on forever. Yeah, we don't want to do those. Hopefully I don't give you any of those. 8 doesn't go into 3, so we're going to go ahead and put our 0, line up our decimal. Now try 8 into what? 30, yes. How many times does 8 go into 30? 3 times. Now we're going to go through the long division algorithm. 3 times 8, yep, that's 24. 30 minus 24, I have what left over? 6 is less than 8. Good so far. Bring down the 0. Keep it going. So 8 goes into 60 how many times? 7 times. 7 times 8, 56. We've got 4 left over. That's a good sign. It's less than 8. Bring down the 0. 8 goes into 40 exactly 5 times. That's kind of important because there's none left over. That means we have our answer. So you have two possible choices. One's easier than the other. I would say this first one is easier, or faster is maybe the right word. Trying to write it as something out of 10 or 100. When you can't do that, you have to divide. You have to use long division. Okay? What if I told you there was one other way? Would you be happy or sad?
Sad.
Well, you shouldn't be. It's really easy.
I'll be happy.
Here goes. 3 divided by 8. We're done. You see, you have to understand that fractions communicate division. Now, I will allow this on harder problems. Okay? But you had to know that division is what is communicated by a fraction. Okay? So this is a way to check our answers. And actually, if you look at example 2 in your book, it says, hey, convert 15/16 to a decimal number. Convert 15/16. That's faster. You just have to know that division is what operation? Oops, sorry. Fractions are what operation? Division. Okay. Sorry, my division is blurred. All right. 2 more lessons. Can we do it? I think so. So I'm leaving space down here for my 74 problems, okay? Lesson 74. So, lesson 75. What else could there possibly be?
Wait, so it leaves more space
Yes.
of another page or...
So no, what I had on my last one, my notes were here. I left the bottom blank for my practice set.
I have like 8 words.
That's probably enough. Okay, so lesson 75, fractions as percents. Oh, I can't write. Sorry, you knew that already. Fractions as percents and decimals. A piece of candy for anybody who knows the name of that symbol.
And... Wait, what?
5%.
Good job, kids.
That's percent.
Oh,
No, sorry.
can I give you candy? Do I have to give you like...
I'll take one. For fractions number 4,
Sorry, the thing blocked it. Luke, give it back. Give it to him. All right. You're going to catch a lot more than candy. Okay, anyways. You've already done this. You did it in the warm-up. We're just putting skills together. Okay? So, 75.1. Let's take a look. How do we write 1/3 as a percent and as a decimal? Oh, I started with a difficult one. Shame on me. 1/3. All right. What do you have to do to get that number, though, Liam? You know that one. I am confident that you just know that one in here. What do you have to do to go from 1/3 to 33.3?
Multiply.
What do you mean?
Multiply it by. Actually, divide it by that first.
If we go through the previous lesson, we're going to say this means 1/3 or 1 out of 3. 1 divided by 3. Let's see if that number that Liam said pops up its head here without dread.
I just rounded.
That's what I said. Okay. So notice I'm going ahead and I'm adding these decimals and the 0 because I know that 3 won't go into 1. And I'm going to go ahead and take advantage of the fact that that's going to be 0 point something. You should know that because 1/3 is between 0 and 1, isn't it? So it is a decimal. It should be 0 point something. Okay? So then we begin. Okay, 3 didn't go into 1. That's why I have the 0. 3 goes into 10. How many times?
3.
3 times. So the 3 is going to go right over that digit. 3 times 3 gives me 9. I'm going to subtract. This is why that long division comes in handy. 10 minus 9 is 1. Now I'm going to bring down the next 0. I'm going to keep going. How many times does 3 go into this 10? 3 times. 3 times 3 is 9. 1 left over. Let's do another 0. Let's see what happens. 3 goes into 10. Wait a minute. This is starting to seem kind of repetitive. Because it is. 3 times 3 is 9, right? Well, let's just do one more. Let's see. 10 minus 9 is 1. 0. Oh, no, it's 10 again. Does anybody know? I know Liam does. Does anybody know what's happening? I got 10 again. I got 10 again. I got.
It's called mirror now.
Why don't we go to our friend just for a minute and let's type it in because we are learning that as a method. Allie, you got an idea? It's just going to keep on going? How long?
Forever. And beyond.
1 divided by 3. Well, I only see 8 there. Does that mean it's forever? I only see 8.
No.
Oh, Corey, you said turn it? Let's see if it gets more. Oh, no, I got a whole lot more now. Does that mean that calculator is more accurate? You see, a calculator is limited to the number of digits it can display. But Allie is correct. It does go on forever. Okay, it goes on forever. So that's where we're going to introduce the concept of a repeating decimal. We're going to say that that's 0.3, and then we're going to put a bar over the top to indicate the 3 keeps showing up. 3, 3, 3, 3, 3, okay? So, that's our decimal. Now we're going to work backwards. How do we change that over to a percent?
Multiply by 100.
All right, you can multiply it by 100. You can think, well, this is like 0.33 if you just write 2 of the infinite 3's. And then how do we say that?
3,300.
33 hundredths, which means what percent?
33.
33. Have I made myself clear about how all 5 of these lessons are connected?
No. Oh yeah, because they're all they're all the same.
Okay. So I'm not telling you to skip over the reading of the examples in lesson 75, but I'm giving you the gist in all of these because it is. Yeah. What if we work backwards? Is that what lesson 76 is? No. But I'm going to give you a backwards one, just for funsies. So 75.2. Let's say I wanted 7%. I want to know what the decimal is and the fraction. So the decimal for 7%.
I know.
Can I tell you what the most common wrong answer is before Liam gives us his?
0.7. A half.
0.7 is the most common wrong answer.
It's point.
Oh, you guys are already ahead of 8th grade. Okay. It is 0.07. Ella, can you tell me why you already knew that there had to be a 0 there? Shh. Hang on. Let's see if Ella can give us what she thinks. What does 7% mean? McKenna?
What?
Did you figure it out?
I hear you.
You were going to tell us why it's 0.07.
Oh, because when there's two digits, it's a tenth, but there's not two digits. It's, I don't know. I can explain.
All right, you're giving me ideas for confusing problems to give you in a second. And then once you get the decimal, it's 7% by definition means 7 out of 100. 7%, 0.07, 7 hundredths. And then as a fraction, there it is, 7 hundredths. Is that what you were going to say, Liam?
I was going to say 7 over 100, but then...
Why not? Why didn't you? You could have said, well, to get the decimal, I use the fraction. And that is perfectly acceptable. So I'm leaving space for 75 here. I'm going to turn to one final page. One final page.
Why?
Lesson 76 is on comparing fractions using, you guessed it, decimals. So this is really one of the big ideas for that activity we're going to do on Thursday. Compare fractions using decimals. So suppose I wanted to know 76.1. This is the problem that we want to be able to solve. Which fraction is larger, 3/5 or 5/8? So comparing, I'm sorry, it's hideous penmanship, but comparing 3/5 to 5/8. Now, before we choose an answer, haven't we already done this?
Yeah.
Yes, we were.
Bristol,
We've done it
you
before.
stretching. We have already done this, not with decimals. You've done this by converting to the same denominator and seeing which one is then larger. Right? Or am I making that up?
You're making that up again.
Really confusing when you do that. So, you already have one tool to use, and that is write them both with the same denominator. Okay? Doesn't involve a decimal at all. So if I wanted to write them with a common denominator, what number would I choose?
3/5.
What? I thought I heard somebody say it.
40.
40. So 3/5 equals how many 40ths? 24. 5/8 equals how many 40ths?
25.
Oh man, they're really close, aren't they? So that tells you this is using old habits, which don't have to die hard. They can still help you. That 5/8 is going to be larger. But the gist of lesson 76 is let's use a decimal to determine that. Let's rewrite 3/5 as a decimal. Let's rewrite 5/8 as a decimal. So 3/5 as a decimal. What would be the easy strategy here? Can you write 5 as a 10 or 100?
Yes.
Yeah, okay, let's do it. What does it become? 6/10. Okay, so I'm going to rewrite this now as 0.6, and then I compare it. 5/8, however, it won't be so easy to multiply 8 by something to get 10, will it? So the other method from the last lesson says, well, we need to do 5 divided by 8 and see what decimal we get. Okay, we need to do 5 divided by 8 and see what decimal we get. 0.625. Now we can see which one's larger. All right, so let's think about this. We want to be fluent and perfect at the way we read this. I don't just want you to say the Pac-Man eats the bigger number. That worked in the past, or the alligator, or whatever you guys used for an animal that goes in here. Let's read it correctly so that we can write the symbol. 6/10 is.
Chop the tree down.
6/10 is less than 625 thousandths. So notice the less than looks like an L for anybody who needs that. Okay. So one final example here. What if we have a mixed representation? So suppose I wanted you to compare the values 40% and 7/16. That number came to me because of measuring tape and things like that. 40% or 7/16. Now, I realize 40% is usually not taken by itself. So we'd want to say, well, can we convert that to something? And maybe you would say, yeah, that's the same thing as saying 0.4 compared to 7/16. But it doesn't necessarily help us yet until we can get them both into a common representation. I had a percent versus a fraction. I have a decimal versus a fraction. I might be closer to an answer, but I don't have an answer yet. So, what do you want to do? Again, lesson 76 is compare fractions using decimals. So it's hey, let's convert that to a decimal. You could think, well, why don't I convert that to a fraction? You could, but you'd still be in the same place. You see, they're not going to have the same denominator. So we're going to convert 7/16 to a decimal. And I'm going to do it by hand instead of my calculator crutch. So 7 divided by 16. We're going to say 16 will go into 7 sometimes. Something. But because it's a smaller number for my dividend, I'm going to have to use the decimal here. Okay? We're going to go ahead and put up here that it's 0 point something, which you should know already if you think about it. It's between 0 and 1, 7/16. Then we're going to start the division process. So how many times does 16 go into 70? Four. Heard somebody say it? I'm going to roll with it. 4 times 16 is 64. Good. I have 6 left over. Now, could we get this answer with the calculator? Yeah. We're going to check it using that in just a second. 4 times 16 is 64. 70 minus 64 is 6. Good news so far. Bring down this next 0. That's why it's important to line that up. It helps you keep track of what you're bringing down. How many times does 16 go into 60? 3 times. Okay, 3 times 16 is 48. I've got 12 left over. I'm going to bring down this next 0. 16 into 120. 7. Yikes. 112, I think. Yeah, that's right. That leaves 8 left over. And I'm running out of space because this one's not going to be a fun 1, 2, 3 digit decimal. What happens here? Well, I ran out of zeros to bring down. Let's just do another one. I promise. There's an end in sight. 16 goes into 80. 5 times exactly. So, what just happened? We converted 7/16 to the decimal 0.4375 so that we could tell which one is larger. Which one is larger? The one with more digits after the 4?
Yeah.
Yeah.
0.4375.
4,375 10 thousandths. That just seems impractical. All right.